All right, so welcome to this video. Today we'll be looking at functions, and we're going to cover a lot of concepts under functions. Okay, so we are going to define what a function is. We're going to look at some mapping diagrams of the functions. Okay, the input, the output. We are going to see how we can determine whether a given relation is a function or it's not a function. We'll talk about the one-to-one functions, which are also called injective functions. Okay, then we'll talk about the quadratic equation. So I have this tutorial sheet with me, which has questions on all the concepts that we're going to cover. Okay, there's concepts on all the questions that we're going to cover. So I was saying we're going to move to quadratic equations, okay, like these ones here. So how can we sketch the quadratic equations? Okay, how can we find the domain and the range for the quadratic equation? How can we limit the domain to actually make these quadratic equations to be what? One-to-one. Okay, we're also going to look at how we can actually complete the square for a quadratic equation. Okay, moving on, we'll look at functions, okay, where we are finding the composite functions, okay, the inverse functions. So you can see these are just composite functions here. Okay, and then we'll also be finding the inverse function, okay, of some of these functions there. Okay, so we're going to find the inverse of different functions, like the linear function, the quadratic itself, the square root functions, which are just radical, the exponential, the log function. We're going to look at how we can find the inverse of all those, okay? And in addition to that, we're going to look at function operations, where we are like adding two functions, subtracting, multiplying, or even what? Dividing. Okay, from there, we'll look at also some quadratic transformations. Okay, and then we'll move now to the applicational part of the topic, what? Functions. Okay, so we'll see how we can apply the quadratic equation, for example, in the measurement of systolic blood pressure. Okay, how we can find the maximum concentration of something using quadratic equations. We are going to look at that, how we can identify or see how the bacteria is growing. So the bacterial growth model, those are modeled by what? By functions. So they're modeled by exponential functions, like this one here. Okay, it just shows you how the exponential growth of the bacteria is going to be what? To be happening. We also look at the application where we're talking about the antibiotic decay models. Okay, so once someone takes the some medicine, okay, how do they decay? How does the constitution of the medicine decay in the person? Okay, so we're going to look at all that as we are solving all these questions that you can see. So there are a lot of questions, and by the end of all these questions, you need to know all the concepts and functions and actually how we can what? We can apply them. Okay, so let's start solving this tutorial sheet. We start from question number 1. Okay, but before we even look at questions, okay, I feel it is important to explain some of these concepts. Okay, so a function is under the umbrella of what we call as a relation. Okay, so we know a relation. Okay, this relation is just it's just simply a relationship between two sets. Okay, so we can have maybe a set A, okay, here, and then we have a set B there. So how the elements of this set A are going to be relating with the elements of set B, that's what we call the what? A relation. Okay, so we can have maybe 1 here, 2, and then 3, and then they have been mapped to 2, 4, and then let's say 6. Okay, so this one will go to 2, this 2 will go to 4, this 3 will go to what? To 6. So we know that we see that there's some kind of relationship between this set and that set. Okay, so if these values here are x and these are y, the relationship here will just be y is equals to 2x. Okay, so if x is 1, y should be 2. Just put the 1 in there. Okay, if the x is 2, you put it there, you get your y as 4. If your x is 3, you put it there, you get your y as what? 6. So a relation is just some kind of relationship, okay, between ordered pairs, like as you have seen here from set A to set B. So we have different types of relations, okay? So I know you know 4 of them. Okay, because that's what you did at grade 12. Okay, so we have a one-to-one relation. Okay, like the one I'm just from erasing here, that was a one-to-one relation. We have a one-to-many. Okay, we have a many-to-one. Okay, and then we have a many-to-many. So these are like four types of what? Relations. Okay, so of these four types of relations, some of them are special relations. Okay, and those special relations are the ones that we are going to be calling as what? Functions. Okay, so in a one-to-one, you just have, if this is X, this is Y, you just have one element being mapped to one like that. Okay, in a one-to-many, you have something like this. So I have my X's here, my Y there. Okay, you have one-to-many. So it means if this is the first element in set X, it's been mapped to maybe one and then two. So we can see that one to many things in the other set here. Okay, so that's the type of relation that we have here. And then we also have a many-to-one. Okay, so many to one will just be like the opposite of this. So I have 2 points maybe here or two elements that have been mapped to the same guy like that. We're going to say this here is a many to one. And then the many to many, I'm sure you can guess what it's going to look like. Okay, so we have maybe two mapping to one. Okay, and then one here mapping to two like that. So we can see that this is a mixture of um, a one to many when we consider this one here. Okay, and then when we consider this one, it will be a many to one. So when we combine them, they give us what? Many to many. Okay, so now I said from these relations, I mean, you're going to get something very special that we call as a function. So now what is a function by definition? Okay, so a function is a special type of relation where each input, okay, each input in the first set is assigned to exactly one output, okay, in the second set. So each input in the first set should have exactly one image, okay? So if we consider a one-to-one, are we going to say this one here is a function? Yes, we're going to say this one, yes, is a function. So why is it a function? Because each input here, okay, is being mapped to exactly one output there. Okay, and then here I have a one-to-many. So is this a function here? Okay, is that a function here? Anyone who can try. Is a one-to-many a function based on the definition of a function that I gave? Is it a function? A many to one. Okay, so based on the definition that I gave, this one here, we are going to say no, it's not a function because here I have one output being mapped to two different outputs like that. But by definition, we said that a function, okay, we said that a function is a type of relation where each input here should be mapped to exactly one output. But we see that this is one output being mapped to what? To two. So this one we are going to say it's not a function. Okay, what about this one? A many to one. Is it a function? Okay, so a many to one, yes, it's a function because each input here is being mapped to only one output here. The output might be the same for this one and this one, but if we consider just this one, we see that it's been mapped to only one. We consider this one is being mapped to only one. Okay, so we're going to say this here, yes, it's a function because each input here only has one image there. Okay, and then a many to many, definitely this one is not a function. So you see that out of these four types of relation, the ones that are function are one to one, okay, and the many to one. Okay, so I should emphasize again, a function is a relation where each input has exactly one output. Okay, that's a function. So we're going to be using this concept here that I was explaining here to solve these questions on question what one, question 1A. Okay, so if you have any questions, please feel free to ask. Okay, so I'll erase this. So just unmute your mic and then you can ask. Don't type in the chat box. I'm not able to see the chat box here. Okay, so let's read the question here now and try to answer. So they're saying, with the aid of a mapping diagram, okay, where X denotes the input elements and Y the output elements, determine which of the following functions, okay, determine which of the following are functions and which ones are not. Okay, so we start with the first one. So the first one is Y is equals to uh, x squared. So they said with the help of a mapping diagram here. So I'm going to draw a set here, x. Okay, I'm going to say this is my x. And then in this x, I'm just going to pick some random variables that I can, random numbers that I can put there. Okay, so I'll say maybe -2, -1, 0, 1, and 2. So this is my set x. And then I'll need to find my set y now using this relationship here. Okay, so here I'm using this relationship. So y is equals to x squared. So my x is -2. What will be my y? Okay, my y will just be -2 and then squared according to this, right? So this will be 4. And then if I put -1 here squared, okay, that will just give me what? A 1. Okay, and then if I put 0 here to just give me 0. If I put 1 to give me back a 1, okay, so there I have to map it like this. So this 0, okay, let me show this properly. Okay, so this 0 was being mapped to what? To a 0. So it's like this. Okay, and then 1 is being mapped to 1 again. And then 2, if I put 2 there, it will be mapped to that 4 again. Okay, so here we see that this relation is what? Is actually a many-to-many. Okay, a many-to-one, I mean. Okay, because I have these two, the -1 and the 1 mapping to 1. So that is many to 1. I have them -2 and the +2 mapping to 4. So that's also many to 1. So many to 1 was considered as a function here. Remember, we said it is a function. Or if you want, you can forget about this. Okay, you can just look at the function that you have. So you make sure that each input that you put here only has one output. So this one is only mapped to the 4. This one is only mapped to the 1. The 0 is mapped to the 0. The 1 is mapped to 1 again, which is just one output. They can be the same output, but we're just considering if I am here, where is it mapped to? It just maps to the 1. Okay, if I'm here on 2, where is it mapped to? It's just mapped to the 4. So this one here, we're going to say yes. Okay, based on this, we have a many to one relation. And the many to one relation, okay, we have discussed that it's a what? It's a function. Okay, so any question on the first one that we have done here? Any questions there? Okay, so if there are no questions, sometimes, I don't know if you've learned that concept. Okay, you can also tell if a function is, if a relation is one-to-one by just using the vertical line test. So the vertical line test requires that you know how to sketch these different types of functions. Okay, so the function that we have here is y is equals to x squared. So that's a quadratic equation that is that has a vertex at the origin here. So this is y is equals to x squared. And then from this graph, you can tell, okay, if it's a function or not. So how do you do that? You use a vertical line test. So you just come on this graph and then draw a vertical line anywhere. Okay, draw a vertical line anywhere that you want. And then you ask yourself, how many points does this vertical line touch this curve that you have drawn? Okay, so if it touches only at one point like that, then you know that it is a function. Okay, I'm going to show you another example. If we draw a vertical line, you see that we have 2 points where this vertical line will touch. So that will not be a function. Okay, so this will mean that yes, it's a function because why? It only touches this curve at one point like that. When you draw a vertical line anywhere here, this vertical line will just touch here, anywhere there to just touch there. Okay, so any questions there, guys, before we move to 2?
I don't understand how you explain the first part where you
Um,
drew the X and the Y.
okay, can you come again? I didn't get the question.
I haven't understood your first solution.
This one here.
Yes.
Okay, so there they said we use mapping diagrams, right? So we're just getting arbitrary points. Okay, you can literally pick any points that you want. Okay, so the relation that we're using is y is equals to x squared. This one, you've seen it, right? So here they told us that the x denotes the inputs and then y are the outputs, right? So for the inputs, we're just going to come up with some numbers, okay? And then from those numbers, we are going to get the output. So the number that we came up with was, the first one was -2, -1, 0, 1, and then 2. So these ones here, you just come up with them. It's you to come up with them, okay? You can literally pick any points. And then now you start using this relation. Okay, so we're going to say this is set x here. Start using this relation to find the values of y. Okay, so how are we going to do that? For the minus 2, we're going to say y is equals to, when x is minus 2, what is y? Okay, so where there's x here, I'll put minus 2. So this will be 4. So this 2 here, the minus 2, it means to be mapped to 4. Okay, so in fact, you should write the y values in order here. I didn't write them in order on the other part. So we had 0, 1, and 4, right? So if I square this, I get 4. So I go like that. Okay, if I square 1, I'm getting 1. If I square 0, I'm getting 0. If I square 1, I'm getting 1 again. If I square 2, I'm getting 4. So now you have this mapping that you have, okay? So you ask yourself, on the 4 types of mappings that we had earlier, okay, where does this one belong? Or where does this one fall? Okay, we see that we have many points here. I have these 2, minus 2, and the positive 2. They're both mapping to the 4. Okay, so these are many to 1. So this relation is many to 1. And we say that the many to 1 is indeed a what? A function. When we are just starting, I don't know if you are there. Okay, or you can forget about this and then just check the output of each element. So make sure that each input value that you put here on the set X has only one output. So if I consider these 2 here, how many output does it have? It only has this 4. Okay, if I consider the minus 1, 1. If I consider the 0, 0. If I consider the 1, 1. If I consider the 2, 4. So we see that each of these X input values here has a unique output value here. And then we conclude that yes, it's a function. Okay. I don't know. Have you understood now?
Yes, thank you.
All right. Amazing. Okay. So now we look at question 2. Okay. So we get familiar with the concepts. So let's look at the part 2 there. So part 2 here is the root of X. Okay, so we know that we can't have a square root of a negative number. So it means the values of X that we pick here should be strategic. Okay, they should be the values that start at 0 and going above. Because if we pick X as maybe minus 4, there's no root for minus 4. Okay, so on our X values, we're going to say the first one we pick 0 and then 1. Okay, we can pick 4 and then 9. So you see that I'm being strategic in the X values that I'm picking here because I don't want to pick any that will give me a decimal number here. Okay, I'm just picking the numbers that I know they will give me a perfect square root here. Okay, so why? What will it be here? Okay, so here, the relation that we are using is y is equals to the root of x. So if my x is 0, what will be my y? To just be y is equals to the root of 0. Root of 0 is 0. So I'll put 0 here. If my x is 1, what would be my y? Okay, to just be 1. If my x is 4, what would be my y? The square root of 4 is what? 2. If my x is 9, okay, what would be the root of 9? To just be 3. Okay, and then you ask yourself now, what type of function is this? This function is just one-to-one. We see that each of these input values, they're being mapped to only one. Okay, so we're going to conclude that yes, okay, this one here, number 2, it's actually a function. Okay, and then if you want to use the vertical line test, later on you know how to sketch all these things. So this one, y is equals to the root of x. It's a graph that goes like this. Okay, so if I draw a vertical line on any point here, you see that this vertical line will just be touching this curve here at one point like that. So we're going to conclude that yes, it's a what? It's a function. Okay, so any questions there? I hope this one is simpler. Any questions there? Okay, so if there are no questions, let's look at this one here. So now this one is a very interesting question here because the equation that we've been given there is actually the equation of a circle. Okay, so you're going to see that a circle is actually not a function. Okay, so we have x squared plus y squared is equals to 9. Okay, so let's make uh, y the subject, or if you want, you can just leave it like that. Okay, so now here, on picking the x values, I'm going to be very strategic. Okay, so I can see that my y is y squared. Okay, so it means to find the value of y, I'll have to be square rooting. Okay, because if I make it the subject here, it will be something like this, to be y squared is equals to 9, and then this x squared goes to the other side, so it is minus x squared. And then I want to find the value of y, right? So I'll square root both sides here. So if I square root where the y squared is, I just end up with the y is equals to. If I square root this side, I'll have plus or minus the root of 9 minus x squared. So we see here that for each value of x, I'm going to have two values of y because one will be positive, the other one will be negative. So already that tells me that this is not a function, okay? But I want to show it using what? The mapping diagram here. So for the x values, I'm going to pick 0, okay, 5, and 9. Okay, so I'm very strategic on how I'm picking these values. So this is my set x, okay? And then I'm going to be using this relation here, or simply this relation here, to find the values of what? Y here. This is my y, okay? So remember my y is given by this equation. So if my x is 0, then it will be y is equals to plus or minus the root of 9, because the x squared there will just be 0. So what is the root of 9? So plus or minus root of 9 is 3. So it means this 0 here will be mapped to two values, okay? Plus 3 and minus 3, okay? What if my x is 5? If my x is 5, what am I going to have? Okay, so here I should have picked 2 and not 5. Okay, because 5 will cause problems. So I should have picked 2 here. And then on the other one, I should have picked 3. Okay, I didn't see the square there. So if my x is 2, then I'll have something like y is equals to plus or minus the root of 9 minus 2 squared. Okay, so this will be what? To be plus or minus root of, this will be 9 minus 4. So 9 minus 4 is just 5. Okay, so it means if my x is 2, my y can either be, okay, plus root 5 or minus root 5. What if my y is 3 here? Okay, I mean if my x is 3, I'll have plus or minus root of 9 and then minus 3 squared. So this gives me what? Plus or minus. This one here will give me 9 minus 9. So this will just be 0. Okay, so my y will just actually here, it will just be 0. Don't follow the signs here. So the things that I have here, it is minus 3 minus root of 5. Okay, and then I have 0, and then I have 3. In fact, I should have root of 5 there, and then 3 like that. Okay, then I can do my mapping now. So this 0 maps to two things. Okay, when my x is 0, remember we found our positive 3 or minus 3, like that. Okay, if my x is 2, we said we are going to find plus root 5 or minus root 5. So I'll go to minus root 5 and positive root 5, like that. And then if my x is 0, I mean if my x is 3, I'm just going to 0 like that. So now you ask yourself, what kind of um, relation am I having here? So we see here that I have one output here, this is 0, okay, being mapped to two different things. So that is one to many, okay? And in our introduction, we said one to many is never a function. So you're going to say no, it's not a function. Or if you want, you don't use that, you just use the same mapping that you have. You go at 0 here, okay? Because we said the function, okay, for each x input, it should have a unique y output. But this x value input here, okay, the x value input here, you see that it has it is being mapped to minus 3, and it's also being mapped to what? To 3. So it has two outputs like that. Okay, so the outputs are not unique. So we are going to conclude that what? This guy here is not a function. Okay, so the circle here is not a function. And you can also show it on a graph. Okay, so if there are any questions, please ask. So on a graph, a circle looks something like this. Okay, so this is a circle. Um, x squared plus y squared is equals to 9. So the radius here is 3 minus 3 minus 3, 3. So how do you get the radius? You just square root the 9 there. Okay, so this is the graph of this function here. So now notice that when I draw a vertical line, it's going to touch this curve at 2 points. It's touching there and it's touching there. Okay, even if I draw it here, it will touch there and it will touch there. I draw it there, it will touch there and it will touch there. So the vertical line is touching the curve at 2 points. Okay, so that simply means that um, the curve that I've drawn, okay, or whatever it is, it's not a what? It's not a function. Okay, so any questions there? Any questions there, guys? Okay, are you understanding? All right. So if you're understanding, then I'm happy. Okay, so let's try to look at the other one there. Okay. So if you have any question, please feel free to ask. Let's try to look at this other one there, the number 4. So number 4, I can see that that is a function there. Okay, just by looking at it. So this is y is equals to the modulus of x. So these bars here, or we call them modulus, they simply mean whatever value of x that we have there, either positive, negative, the output should be a positive value. Okay, so it's the same as x squared in some way. Okay, but its graph is going to differ. This one will have a sharp 10, and then this one here, the x squared has a smooth 10. So here I can literally pick any value of x that I want. So I'm going to say my set x here, okay? My set x here can be anything. So I can just say -2, -1, 0, 1, 2. Okay, and then what will be my set y here? So my set y, it will be based on this equation here. Okay, so this equation we said if it has bar, then it's just making whatever is negative to be positive. Okay, so you still have the same numbers, so it will just be 0, 1, and 2. So what we have is that this 2 is going to map to 2. Even this 2 here is going to map to this same 2. Okay, this one is going to map to 1, the -1. And then the +1 is also going to map to this one. Then the 0 is going to map to the 0. Okay, so on the type of relations there, we said that this one, okay, if I consider this out, if I consider this input and this one, we see that they've been mapped to the same output like that. Okay, so this is a many to one. Okay, so we said many to one. Yes, it's a what? It's a function. A many to one is a function. Or if you don't want to consider that, just look at your mapping. Okay, I come at -2, at -2 here. Where is it mapped? It's only mapped to the 2. Okay, I come at -1. Where is it mapped? Only to the 1. 0, only to the 0. 1, only to the 1. Okay, so the outputs can be the same for different x element, but as long as that x element is just being mapped to 1, okay, we call it as a function. So this is a function. Okay, so when we draw that curve on the x or y plane, this is my y, this is my x, it will be a v on the origin like this. Okay, so it will have a sharp 10 on the origin. So if you draw a vertical line anywhere, there, there, you see that this vertical line will be touching these things only at one point, like that. Okay, so we're going to say yes. This confirms that indeed this is a what? A function. Okay, so I'll do the last one, and then the other one, maybe I can leave it for you guys to try. Okay, and then if you have any questions, feel free to inbox me. Okay, so let's look at question 5. Okay, so question 5, I can already see that it's not a function, but I haven't been solved. Okay, so y squared is equals to x. So this simply means what? Okay, so this simply means for any x value, I'm going to have two y values, and that won't be a function. Okay, so how am I doing that? I'm making y to be the subject. So if I make y to be the subject, I'll square root this side. I'll just get y is equals to. If I square root this side, I'm going to get plus or minus the root of x. Okay, so now we can pick the values of x in a very strategic manner. Okay, because the root of x there will only take non-negative values. So like 0, 4, and maybe 9. Okay, and then here I'm going to have my set of y values. So y values will be depending on this equation here. So if my x is 0, then I'll definitely have a 0, 0 there. Okay, if my x is 4, I'll have plus or minus the root of 4, which will be plus or minus 2. Okay, if my x is 4. If my x is 9, I'll have plus or minus what? 3. So what I have in this set is -3, -2, 0, 2, and then 3. So now I can draw my mapping. So this 0 goes to the 0. Okay, the 4 goes to the -2 and the +2. Okay, so it goes there and then it also goes there. Okay, we see that this one already defies the law of a function because it's one input having two different outputs. Okay, the 9 will go to -3 and to the 3. Even this guy defies it. Okay, so we see that this one here won't be a function. So we say no, based on the mapping here. So these are the y values. Okay, if you want to show it on the graph, okay, the graph of y squared is equals to x. It's just a quadratic equation that opens in the positive x like that. Okay, so this one here is y squared is equals to x. So if we draw a vertical line anywhere here, we see that this vertical line will cut this guy at 2 points like that. Okay, so we're going to conclude that that one is not a function. Okay, so Natasha, you've raised a hand. You can ask. I've seen you've raised a hand. Or is it a mistake? Okay, so someone is saying, why did you say root x? Okay, so here I was just trying to make y the subject of a formula. So what we were given here is this. Okay, so uh, when we're dealing with functions at your level, okay, you always make y to be the subject. Okay, so that's what I was doing here. So how do we make this y to be the subject? I square root this side, this square root and the square will cancel, so I only remain with the y. Okay, and then when I square root the other side, okay, because it doesn't have any square on the other side and I'm just introducing the root, okay, then I have to put plus or minus, okay, plus or minus, because I know that if I get minus 3, I square it, it's going to give me 9. If I get positive 3, I square it, it's still going to give me 9, okay, so the square root there should have two values. So that's where we're getting this root of x there. Okay, so any questions there? Okay, so thank you so much for watching this video. If you'd like to access the full video solutions, okay, to all the questions in this tutorial sheet, plus all the other tutorial sheets that are there, okay, we have the videos available and you can actually access them at discretelearning.com, okay. So once you subscribe with us, you access full videos to all these questions, okay, plus all the other tutorial sheets, okay. And it's not just math that we offer, we also offer biology. Okay, so you can subscribe for biology, or if you want, you can subscribe for physics, chemistry, mathematics. Okay, if you subscribe for any of these courses, what you get is full videos for all the tutorial sheets that you have, the assignments, the tests, and the past tests. Okay, so the quizzes and the past tests, so that they help you prepare for your tests and the final exams and the like. Okay, you get full solutions to final exam papers. Okay, mid-exam uh, uh, papers, you're going to get access to all those videos. Okay, we're also allowed to consult from us. Let's say you're watching a video and you do not understand some concepts, you're free to text us on any of these numbers that have been given there. Okay, so you can access all these at discretelearning.com. So if you just want to subscribe, you can contact any of these numbers here, or actually just check the link in the description below here. It's going to show you a video, okay, the registration guide that shows you how you can create the account on our website and how you can access and um, learn, okay, anything that you want from there. Okay, so for those who have never seen our website, okay, let me just show you here. So you just open Chrome, okay, just open Chrome either on your phone or your PC, and then you type in discretelearning.com. So you can see the discretelearning.com there. Then you just click search. Okay, so once you search, it will take you to our website. Okay, so if you do not have an account, it will take you to the login page. On the login page, there's a part where you click to create an account. So you create an account first. Okay, so you just put in your simple details like your name, your email, and you set a password for your account. Then using those same details, you'll be able to log in. Okay, so once you log in, these are the courses that you find, okay, for first years, mathematics, chemistry, physics, and biology, and you can learn, okay, anything that you want from there because the videos are there. Okay, plus we also have live classes where we can interact with your students. Okay, so for example, if you've paid for math, you can simply come here and open this course, okay? Once you open, you see the folders there. So it depends with the university where you are. So if you're not at Apex or Unilas, you go in the general mathematics folder. That's where you'll find your things. But if you're at Apex or Unilas, you go to your specific folders, right? So for example, that tutorial sheet on functions, okay, it was from Unilas. So just click on the Unilas part there for first semester. Okay, it opens, so you can see there are topic lessons there, there are summarized notes, there are tutorial sheets, and then there are past quiz, test, and exam what? Papers. So if you want the tutorial sheet, just click on the tutorial sheet there. Okay, click on the tutorial sheet, and you see there are different intakes. So the current one is 2026, but if you're watching this in the future, okay, even the tutorial sheet for intake will be available here. So I'll just click on the 2026 January intake. You can see all the tutorial sheets are there with full videos. Okay, tutorial sheet 1, 2, 3, 4, 5, 6, 7. All of them are here and you can learn at your own time, at your own pace. Even the assignments are there. Okay, at your own time, at your own pace, even in your blanket. So it's the same. Even if you go to the physics folder, chemistry, biology, you still find helpful information that can help you learn and pass your what? Your exam. Okay, so if you want the past papers, okay, just go to the uh, folders for the past papers. Okay, so okay, let's just wait for it to load so that I also show you the past papers. Okay, so I'm back in the folder here. I can click on past quiz, test, and exam papers. Okay, you'll see you're going to find some video solutions here for the quizzes, for the tests, and for the final exam what papers. So you can see all these videos here can actually help you to pass your what? Your exams. Okay, so feel free to register on this platform. It is very helpful. Okay, if you want to contact me, my number is 0779 96 40 10. So that is Tutor Post Solutions. Okay, so you can contact me and we'll start helping you. Okay, but if you want to just do it on your own, you can also do it without contacting me. So just check the link, okay, in the description here. It has a video, okay, which we are calling as the video registration guide. So it will tell you how to create an account on this platform, how to pay for the courses that you want, and how to access everything that you want. Okay. Okay. And then if you have an Android phone, for now, you can also go to Play Store and install our mobile app. So just search Discrete Learning Institute, okay, on the Play Store. The mobile app is going to come, and on the mobile app, you can actually download all these videos and watch them what? Offline. All right. So thank you so much for watching this video. This has been Tutor Post Solutions. Until next time, always there for you.